intense online match, right? You line up that perfect shot. You click, boom, you get the point, and it feels instant. But in that tiny fraction of a second, a little piece of your data just went on this absolutely incredible journey. And today, we're going to follow it.
I mean, have you ever really stopped to think about it? You're sitting in your house, your friend is maybe hundreds of miles away, yet somehow your actions in a game seem to happen in their world at the exact same time. How? How does that even work? It feels like magic, but it's not.
And that right there, that's the big question we're tackling. We're going to follow that single bullet of data, from the very moment you click your mouse, all the way across the internet, landing right on your friend's screen. It's a way more complex and, honestly, fascinating trip than you might think.
Okay, so here's the 30,000-foot view, the roadmap for our bullets journey. First, it starts right there in your house, on your local network. Then, it zips across the wide area network, which, is just the fancy term for what we all call the internet. It hits the game servers, and then it has to travel all the way back across the internet again to finally show up at your friend's house. And the crazy part, all of this happens in like the blink of an eye.
So, that's the big picture. But to really get how it all works, we've got to zoom way in. We need to look at the fundamental building blocks. So let's start from square one, the absolute simplest network you can possibly imagine.
Yeah, let's actually rewind the clock a bit. Because way before we had these massive online games, before the internet was even a thing, networking was created to solve one very, very simple problem.
And this is it. This is the whole reason networking exists. At its core, it's just about letting computers talk to each other. I mean, think about it. One computer has some data, and another computer needs to get that data. That's literally it. The very first networks were just about connecting two machines so they could share stuff. You could even do it right now, just by plugging an Ethernet cable between two computers.
Okay, so one cable works perfectly for two computers. But what happens when a third computer wants to join the party? Or a fourth? What if you want to add a printer to the mix? All of a sudden, that super simple setup just completely breaks down. We've hit our first big problem.
And the solution to that problem is this little guy, a switch. The best way to think of a switch is like a digital intersection, or maybe a roundabout for your data. It lets a whole bunch of different devices, computers, printers, you name it, all on the same network, talk to each other without any issues. Now, we're keeping it simple here. We're not getting into the weeds with things like MAC addresses just yet. The main takeaway is this. A switch is what makes a local network, like the one in your house, actually possible.
All right, so we've got our local network all set up, thanks to the switch. All our gadgets can chat with each other. Awesome. But what happens when we need to talk to a device that's on a totally different network somewhere else?
And this brings us to the next big challenge. Let's say we have Bob on network 1 and Mark on network 2. The switch in Bob's house connects all his devices, and the switch at Mark's place connects all of his. But Bob and Mark, they're completely isolated from each other. So how do we build a bridge between their two separate worlds?
This is where the router makes its grand entrance. So, if a switch connects devices inside one network, a router's job is to connect different networks to each other. It's basically the mailman or the traffic cop that directs data from one digital neighborhood to another. And the really cool part is, it's not just blindly forwarding your data, it's constantly talking to all the other routers out there, figuring out the absolute fastest, most efficient path for your information to take in that split second. It's making an intelligent choice, not just a random handoff.
And when you understand that, you suddenly get the big secret of the internet. It's not some magical, mysterious cloud floating up in the sky. It's really just a gigantic network of networks, millions of them, all connected and talking to each other using routers. So that bullet's journey we're tracking, it's really just hopping from one smart router to the next at mind-boggling speeds.
Okay, so we've got the basics down. Switches handle our local stuff. Routers handle the global connections. The foundation is set. But for a modern network to actually be useful and, safe, we need to add a couple more key ingredients to the mix.
First things first, security. Look, the internet is an amazing place, but let's be real, there's also some sketchy stuff out there. That's where a firewall comes in. Think of it like a digital bouncer or a security guard for your entire network. It stands right at the front door and inspects every single piece of data that tries to come in or go out. And what's really cool is how it thinks. It's not magic. It's really just like a bouncer at a club with a guest list. The firewall has a set of rules, right? And it checks every packet of data against those rules. So, the data from your game, yep, on the list. Let it in. That website you just asked for, you're good to go. But some random, weird connection from across the world trying to poke at your computer? Nope, not on the list. Access denied.
Okay, so I know what you're probably thinking right about now. This is all fine and dandy, but I'm on my phone or my laptop. There are no cables plugged into this thing. And you are 100% right. Most of us are connecting wirelessly these days. So where does Wi-Fi fit into this whole picture?
Well, that little bit of magic comes from something called a wireless access point, or a WAP. What it does is actually pretty simple. It takes that cabled network that we've been building and just broadcasts it out through the air using radio waves. This is what allows our phones, our laptops, our tablets to all connect and join the network conversation without needing any pesky wires.
So let's recap. We've got these four main pieces: a switch, a router, a firewall, and a wireless access point. But if you go look at the little box your internet company gave you, it's probably just one box. So what gives? Why is that different from what you see in a business where they have whole racks full of equipment?
Well, that box in your home is basically a Swiss Army knife. It's a router, a switch, a firewall, and a wireless access point all squeezed into one convenient little package. But a big business network that has to serve hundreds, maybe even thousands of people, they can't use a multi-tool. They need specialized equipment. They have separate, dedicated devices for each job because they need way more power, more features, and more control to handle that insane amount of traffic.
So, we have all this incredible technology, all this hardware that literally makes our modern digital lives possible. But here's the thing. This gear doesn't just configure itself. It doesn't just work out of the box. So, who are the people that actually design, build, and maintain all of these complex systems?
Well, that would be the job of a network engineer. These are the architects of our digital world. They're the ones who make sure all of these different devices play nicely together so that your data, our bullet from the game, can make that amazing journey perfectly every single time you click.
And this right here, this is their toolkit. Everything we've just talked about, the switches, the routers, the firewalls, the access points, these are the fundamental building blocks. These, plus some even more advanced gear, are what they use to build and maintain the networks that we all depend on every single day.
And hey, if any of this has sparked your interest, if you're thinking, wow, that's actually really cool, there's a very clear path to learn more. For anyone who wants to go from just understanding these ideas to actually building with them, certifications like the CCNA are basically the roadmap. They give you a structured way to really master this stuff.
So there you have it, from one single click in a video game all the way out to the massive global infrastructure that makes it happen, you now know the fundamentals of how our digital world is connected. The internet isn't magic, not at all. It's brilliant engineering. And the only question left is, are you ready to learn how to build it?